In this video, we're going to revisit the idea of writing proofs, and the proofs that we're going to be writing are going to be centered around the concept of a transversal and parallel lines. Recall that in Euclidean geometry, it is assumed that parallel lines never intersect. This leads to the corresponding angles conjecture, which says that the corresponding angles are congruent. Alternate interior angles, alternate exterior angles, those are going to be proven from this conjecture. So we don't really make the assumption that all three pairs of angles are going to be congruent. What we do is just assume that the corresponding angles are congruent. And then if that is assumed to be true, we can actually prove that these two would also be congruent. In example number 1, what we will be doing is proving AIA. That would be the alternate interior angles. The converse of each statement is also true. This means that lines can be proven parallel if certain angles are congruent. Now remember that converse can be thought of as backwards. So we can do two different things here. We can either prove that angles are congruent because lines are parallel, or we can prove that lines are parallel because the angles are congruent. For example 1, we're going to prove that alternate interior angles are congruent. That would be if the transversal is crossing parallel lines. All right, if the lines are not parallel, that wouldn't actually apply to what we're talking about here. All right, so let's take a look at the picture. P and Q, the lines that we have here, they do have the little arrow markings on them, which will indicate that they are running parallel to each other. All right, so here's going to be our proof. The given information is that P is parallel to Q. Okay, if that was not provided here, if we did not have these as being parallel, then all this stuff about the alternate interior angles being congruent wouldn't matter. Okay, so this is our given information, and that is also going to be our first step here, which means that our first reason is given. That is given to us. All right, step 2 says that angle 1 is going to be congruent to angle 3. Let's go ahead and take a look at the picture. Angle 1 is congruent to angle 3 because they are corresponding angles. All right, now recall from the beginning of this that the different angle pairs that we have, the pair that we assume to be congruent is going to be the corresponding angle. So that would be 1 and 3, that'd be an example there. Angle 3 is also congruent to angle 2, and that is because they are vertical angles. And then for our last step, we've got angle 1 is congruent to angle 2. Okay, now angle 1 and angle 2, those are alternate interior angles. That isn't going to be the reason for this. You're not going to write down that they're congruent because they're alternate interior angles. That's actually what we're trying to prove, is that alternate interior angles are congruent. The reason that these two are going to be congruent is because of the transitive property. All right, so where does that come from? The lines that preceded it, angle 1 was congruent to 3 by corresponding angles, and 3 is congruent to 2 by vertical angles. So if we take out angle 3, we can match up angle 1 to 2. For example 2, we're going to be thinking converse. That means that we are going to be proving that lines are parallel. We're going to prove that the lines are parallel by identifying a pair of angles that would be congruent. Our given information here is that R is parallel to S. I'm going to go ahead and add some arrows on that just to indicate. That is given to us. Angle 1 is congruent to angle 3. All right, so these two are congruent. They're pretty far from each other. Okay, so they're providing that for us. These are congruent. What we have to do is prove that P is parallel to Q. Now in the picture, they obviously appear to be parallel, but remember what we're trying to do here is prove that they are parallel. For our proof, the first 2 steps are actually our given information. Step 3 says that angle 1 is congruent to angle 2. Okay, in the picture, we've got angle 1 here, and there's angle 2. It claims that they are congruent. Well, both of these are going to be in the top right corner of their respective intersections, so they could be corresponding angles. But are they congruent? Well, it depends on the lines that make them. The S and the R, those 2 lines are given as being parallel, and Q is a transversal between them, so yes, these 2 as corresponding angles are going to be congruent. So we can just write that down, corresponding angles. All right, and then step 4 says that angle 3 is congruent to angle 2. In the picture, here's angle 2 and here's angle 3. These are alternate interior angles. They do fit that definition. okay? But we don't know that they're congruent by AIA because we don't know that P is parallel to Q. So you can't use that. They are alternate interior, but that won't be the reason why they are congruent. The reason that they're congruent is going to be the transitive property. Again, look at the steps that precede it. Line 2, 1 is congruent to 3. Line 3, 1 is congruent to 2. 3 and 2 are both congruent to 1, which means you can take that out and just say that angle 3 is congruent to angle 2. Transitive property. Now, yes, these are alternate interior angles. These are. Okay, so to prove that P and Q are parallel, what we can do is use the converse. If we can identify a pair of alternate interior angles that are congruent, which we did, then you can use the alternate interior angles to prove that the lines are parallel.
Later, blah.